here talking about practice. I mean, listen, we talking about practice. Not a game, not a game, not a game. We talking about practice.
Yes, thank you, Alan Iverson. We are talking about practice because practice makes perfect in a geometry class. So let's get to 4-4 here. Our section title is using congruent triangles, CPCTC. You're going to hear that a lot. Our objective is to use triangle congruence and CPCTC to prove that parts of two triangles are congruent. So here, take a look at the two figures. Are these two triangles congruent? Well, we have angle, angle, yes, side, and side, and then another set of angles congruent. So wait, what was that? Angle, side, angle with this angle, side, angle. Okay, so the two triangles are congruent. Once you know that, what else can be concluded? Well, let's see. The missing angle, angle B and E, are these congruent too? Well, yeah, of course. If the two triangles are congruent, yes, they are. How about AB and DE? Would those be congruent? Yeah, of course. And same with BC and EF. So what is CPCTC? I would take a look down here. It stands for corresponding parts of congruent triangles are congruent. So what does corresponding mean? That just means that it kind of like matches up. So if we go back to our picture here, basically what we're doing here, once we prove that the two triangles are congruent by ASA, then we could say, all right, well then all corresponding sides are congruent and all corresponding angles. So BC with EF. Again, this shouldn't be too bad. Just corresponding parts of congruent congruent triangles are congruent. So again, you could read through this. That's just exactly what I explained, what we will be doing with this. Pretty cool transition there. Now we get to some proofs. So we have angle Q congruent with angle R. Okay, so one set of angles. And then QPS right here with RSP, this angle. And we're trying to prove, it's not two triangles congruent like we were used to. Here we're trying to prove two sides congruent. So we might, a little hint, we might be using CPCTC, CPCTC, CPCTC. I like repeating that, CPCTC. Alright, so let's see. Angle, 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 angle. Are these two sides congruent in between? No. How about this side in the middle? Yeah, I think that is. That's reflexive property, right? So we'll start off with our givens here. And then PS right in the middle, as we said, is congruent to PS by reflexive property. Then the two triangles are congruent by angle, angle, side. And now we're trying to prove SQ is congruent to PR. So SQ here, congruent with PR here. And that would be true by CPCTC. Yes, CPCTC. Good. Alright, last proof here, we have DE bisects angle FDG. So this angle FDG is bisected. So what's that going to mean about this angle right in here with this angle? Well, they'll be congruent. Then we'll have what? A side and then an angle with this side and angle. And let's just double check. What are we trying to prove? Not that the two triangles are congruent, but we're trying to prove just angles. So we're probably going to use CPCTC. And let's see, all right, given, good. Again, why were these two angles congruent? By definition of angle bisector. And then FD is congruent to GD, that's given. Then DE, okay, this is our basically given one, reflexive property. Right in the middle, it's split right in the middle. And then, all right, the two triangles are congruent by SQ With this SAS. Very good. And lastly, are angle F and G congruent? Yes, they would be by, everyone say it, CPCTC. Good. And that is it for today. Thank you for listening.